This is part 3 of section 1.7. The symmetry property of the graphs of a function and its inverse. The graph of a function, a one-to-one function f and its inverse, they're symmetric with regard to the line y equals x, which is your constant function. If we look at this example problem, we are given this graph of f, and we are asked to use this graph when we don't know a formula for it whatsoever. We're asked to use the graph to develop the graph of the inverse. Well, all that's happening when we think about if you take your x and you go to your y, the function takes the y and goes to the x. All we are doing is flipping every ordered pair. So if I just go through this list, the ordered pair 4, 3, I'm going to move it to the point 3, 4. So 3, 4 will be here. I have the point -1, 2. I'm going to reflect that over to the point 2, -1. So 2, 2, -1 would be here. And then I have -3, -4, and it's going to be reflected over to -4, -3. So -4, -3, unfortunately, is in the middle of that printed ordered pair. And then you connect your points, and you will have your graph. Notice that the graph of the inverse is also a function. It would also pass a vertical line test. Okay, so let's talk about how we actually find that inverse function. The steps are pretty easy. The first thing we do is where we have an f of x, we're going to write a y. And then we're going to flip our x and y around. We're going to solve for y. And then we're going to write f inverse of x for our y. Okay, so let's try it. We are given a function. We want to find the inverse and then use that to find the domain and the range of our original. So just looking at our original here, f of x is equal to 2x plus 3. This is linear, so there are no issues in the domain. The domain of this is going to be from -infinity to +infinity. And I just need to find the range. Okay, so now let's go through this process. Where there is an f of x, I write a y. Now, everywhere there's a y, you write an x. Everywhere there's a x, you write a y. So I have x is equal to 2y plus 3. Solve this for y, subtract 3 from both sides, and then divide by 2, sorry, and I get x minus 3 over 2 is equal to y. And then our last step is to write f inverse of x is equal to x minus 3 over 2. So this is the inverse function. I have the domain, I just need to find the range. And the range, I look right here because the domain of this is going to be the range of this. If I look at this at the domain, well, actually, they may write this instead of like this. They might write it like 1/2 x minus 3/2, in which case it's pretty obvious that it is a linear function, and since there are no x's in denominators or under a radical, then the domain of this is also all real numbers, so the range of our original is all real numbers, -infinity to +infinity.